And let's get started with the driver fundamentals. And in driver, whenever you are learning, the first thing we need to know about is the kernel module. We are going to see what the kernel module is. But before that, let's understand all this stuff, what the driver is, how does the driver ecosystem looks like, Linux kernel source code organization. I will briefly take you through the source code, what all different folders exist at the high level, Linux kernel module, and by the end of this session, we should be comfortable writing a very basic driver. Okay, and we should be able to load it, we should be able to unload it dynamically on the fly. So let's see how does the things work. So first of all, what the driver is. So whenever I basically ask this question, anyone, the first answer which basically I get is like driver is something which manages the hardware. It is something which provides the security. It is something which basically monitors the hardware. Yes. So if you ask me, this particular definition is partly true. When I say like driver is the one which will be managing the hardware, it is the one which will be controlling the hardware. Uh, it provides the abstraction to the hardware. So all those things are true, and 99% of time that's what the driver does, but not always. Okay, not always, because there might be scenarios where there is no hardware, but whatever driver we write, whatever code we write, in a kernel space, we still call it as a driver. So what actually is the driver then? Driver, if you ask me, is a piece of software which drives, monitors, operates, controls something. Now that something can be another piece of software, it can be pure algorithm. You basically have lot many drivers which are just the algorithm and independent of the hardware. Okay, and they basically work even if the hardware is not there. Let's say on the memory itself, these particular drivers will be able to work. Now, another category of drivers which we have which operate on device, and that's what we call it as a device driver. So when I say driver is the one which monitors the hardware or controls the hardware, those things we call it as a device drivers. So in a nutshell, every device driver is a driver, but other way around is not true. Every driver is not a device driver. It's not necessarily a device driver. There are some drivers which we'll be seeing in a while, which are like a pure algorithms, and still they are the driver. Okay, so the piece of software which drives, monitors, operates something, that something can be another piece of software or it can be a device. If it is operating on a device, we call it as a device driver. But what definition we were referring to is what the driver is. Okay, so hope this definition is clear to everyone. If there are any questions, do let me know. All right. So now, why do we need the driver? So now the important question which comes is like, why do we need? So typically, again, the answers which I get over here for security reasons, so that application code should not touch the hardware directly and all those kind of things. Yes, those are basically the secondary things. But the reason we need the driver is something called abstraction. Okay, what do I mean by abstraction? See, it has been the philosophy, it has been the OS philosophy right from the beginning that as an application developer, I should not be bothered about the nitty-gritties of the hardware. How does the hardware operates? Like what thing I need to do with the hardware to make that work? Those all things should be abstracted out. So most of the times, the very I can say simple example which I give to my participants is something like this. So let's say you are writing an application, and in the application you are using scanf. Okay, scanf percentage C, and get that particular into this particular variable C. And here, uh, whatever the user gives the character, you want to get it into the this particular C variable. And now what you do over here is, over here, you have a keyboard and the user will be pressing a key on the keyboard and you are going to get it. So internally, there has to be the keyboard in the hardware space, and this keyboard will provide you this particular character C. Now, most of the times we assume that from the keyboard we get the ASCII value. That means when you press A, you are going to, for the small a, you are going to get 97. For capital A, you are going to get 65, and you are going to get kind of like a ASCII value of the character. But that's not true. Keyboard doesn't provide the ASCII value. What keyboard provides is something called the scan code. Okay, scan code. And typically there are three types of keyboard. There are three types of scan codes. Okay, so let's say when you press A, it is very well possible that over here you will be getting something like 0xC, or that whatever the scan code will be, 0xC, for example, corresponding to the character A, the keyboard generates the scan code C. Corresponding to character B, it, let's say, it generates 0xe, something like that. So now if I directly take the input of this keyboard at the application level after the scanf, let's say if I get C is equal to, for example, I get, sorry, if I get over here 0x C, then I need to say, okay, this C is equal to, I need to assign it the character A. So all those kind of stuff you will have to do, and not only that, you basically need to check which kind of scan code keyboard you have connected, whether it's a scan code one type of keyboard, scan code two types of keyboard, or scan code three type of keyboard. So as a application writer, you need to take care of these particular things. So with whole this thing, what happens is your application development becomes complex. Apart from this, your code is not portable. Let's say tomorrow the fourth scan code comes, you'll have to change your code as per the as per the keyboard, whatever the new keyboard is introduced. So I don't want to make my application hardware dependent. Okay, I don't want to basically know the nitty gritties of how do I operate on this. I should be completely, I can say, as an application developer, I should not at all bothered about these kind of things. And that's where what happens is over here you have something like a keyboard driver. For a particular keyboard, you have a driver. Now, conversion of the scan code to the ASCII value is being done by the keyboard driver. And this keyboard driver will do that conversion at the application level. You just do scanf, no matter what kind of keyboard you have, these things would be taken care of. So that has been the philosophy of the OS developers. That means at the application developer development, you should not at all bother about the hardware and all those kind of stuff. So that has been the reason why you have the driver. And then of course, along with it comes the security and all those kind of stuff. This keyboard kind of stuff over there. Okay, yeah, keyboard. Now you see there are keyboard drivers which are available to us, and this is what will be doing the stuff. KBD. Okay, there is something like hilkbd.c, and here there should be some scan code mapping and all those things happening. Just wanted to show you. Yeah, see, it is like this. You see, scan code, handle status, handle data, all those things. The driver is doing that. Okay. So I want to give this as an exercise to you guys in the Linux kernel internals. That's what my plan is as a part of interrupts. Okay. So we'll see that. Okay. So the need for driver abstraction in order to provide the abstraction. Okay. Now coming to the very important I can say, topic of this whole chapter. And from the driver perspective, it's very, very important. The Linux driver ecosystem, which will give you the complete information about how the whole system is being laid out. Okay, in the sense, in the kernel, how all the drivers are placed, what role do they play, in which category they fall, all those kind of things we are going to see it as a part of this. So based on the OS specific interfaces the driver provides, in Linux the driver is categorized into three. One is basically the networking vertical, or we call it as a packet oriented. Another one is a storage vertical, or we call it as a block oriented driver. And third and the final one, which we have got, is something like a byte oriented, or we also call it as a character vertical. So, networking vertical, storage vertical, and the character vertical. So, these are the three categories of the drivers which we have got over here. Now, considering these two other stuff, where you have the memory management vertical and the process management vertical, where we can say that the processor is a device and we have a driver for that, and memory is a device and we have a driver for that. If we basically refer these two, if we put together these two along with these three verticals, it will give us the complete textbook like definition of a Linux kernel. That means operating system. So typically operating system does five tasks: process management, memory management, network management, storage management, and IO management. So these five verticals put together give you a definition of a Linux kernel as performing five tasks. The OS performs the five tasks. So here I can say that this is like a processor driver or memory driver, but you would have rarely heard these terms. I can say you would have never heard those terms where I can say driver for the processor, where I can say driver for the memory. Why don't we use those particular terminologies? Because be it any kernel, like a microkernel, monolithic kernel, or whatever type of kernel you say, memory management and the process management are the core functionalities of any kernel. If you don't have memory management or process management, the operating system itself is of no use, because these are the two primary functionalities. And another thing is, whenever we do this coding related stuff for the processor or the memory, it's typically the part of the porting activity, which we call it as a BSP development or architecture kind of porting. So hence, be it any form of kernel, this is the core part of the kernel. This forms basically the core of the kernel, core code of the kernel, and we can't actually call them as a drivers. So henceforth, whenever we refer to the drivers, they will fall into one of these categories, which can be networking category, storage category, or IO or character vertical category. So these can be one of the three categories to which your driver will belong. There will not be something like a memory driver. There won't be something like a processor driver, because they are the part of BSP. They are the core functionalities. Without that, your kernel can't function. So henceforth, whenever we talk of the drivers, it will fall into these three categories. So now let's dive a bit deeper. Let's dive a bit deeper into this particular verticals. Now, if you see this networking vertical, it has been split into two parts. What are these? One is basically the protocol stack. So, as we understand, typically in the Linux, we have the protocol stack. There are actually something like you have the transport layer being implemented. If you go by OSI layer, then application and the session layer happens in the application space, and then so if I say something like this, what we have got is there is an application space. That means when I say user space, so you have the application layer, and you have a session layer of the OSI model. Okay. And then over here comes the transport layer, where you typically implement the socket programming. Then beneath this, you will be having a network layer, all the IP related stuff, packet, and all those things will be handled over here. And then you basically have here the, so we have one, two, three, four, and then the seventh will be the physical layer, will be the 5, and above physical layer we should have a data link layer. Data link layer in between I'm missing one layer. One, two, three, four, five, six. Data link layer. One layer I'm missing here. Transport layer, network layer. Yeah, anyone knows, just let me know.
Presentation.
Okay, yeah, I think those all layers are here. Okay, okay. Application presentation. So I think these all layers are here because underneath we have just this. Yeah, good, good. Presentation and session layer are same, or let us do the search. Okay, OSI layer. So if you have, yeah, session, presentation, application, it comes there itself. Okay, so session, presentation, and application, and here we have a data link layer and the physical layer. So these are basically, out of this, what happens is these are the pure software stuff, like your TCP IP or datagram and all those packet uh, headers addition and all those kind of things. It happens in the kernel. Okay, this is happening in the kernel related stuff. Uh, this is basically hardware independent part, and this one for 5 you might or might not need the driver. Okay, so this thing is basically your driver. Okay, now you see over here what we have done is, in our diagram, this networking stack or subsystem is something which is handling this part. It's handling this part. Apart from this, it will be providing you the hook so that you can plug any of this, because your ethernet driver might your nic card might change from the hardware to hardware, so it will be providing all the apis to register with this layer, and all those kind of networking related stuff is going to come as a part of this. And physical layer, you typically use the mdio interface to interact with that, and this is the one which will be sending the data finally on the wires. So the point which I'm trying to make over here, why did I go this deep, is this whole part comes in the part of networking stack, which is independent of the hardware. Irrespective of whatever hardware you are dealing with, whatever the uh, header, putting the header, removing the header, all those kind of things you will be doing. And apart from this, the networking layer related stuff, that means providing the APIs, uh, providing the corresponding APIs to the lower layer, will be done at this part. For example, managing at this layer the something like receiving the data from the user space, providing the socket layer, and all the socket related stuff will be done in this particular stuff, which is independent of the hardware. This is where your Mac controller gets implemented. Okay, controller driver, NIC driver will be coming in the data link layer. So this is this part. Okay, network interface card driver. Let's say you have it from the Realtek, or you have it from the uh, Intel, or you have it from the Athros, or from whoever vendor. You will be having a corresponding hardware specific driver. So the reason we have this split is, we have split it on the basis of hardware independent part and the hardware dependent part. That's why we have this split. Okay, so hope it is making sense. Like networking vertical is being split into two parts, and the reason is we have the hardware independent part and the hardware dependent part. Okay, now let's move on. Now we have another layer which is again split into two parts. This we call it as a storage vertical, and this particular storage vertical is being split into file system drivers and the block driver. Now, what is file system driver? The algorithm, the pure algorithm. Something like you say ext2 file system, ext3 file system, ext4 files, NTFS file system. Then you basically have the FAT32 file system, which is nothing more than an algorithm. And what it does, it provides the methods and the data structures to organize the files on the disk. Okay, so that is what the purpose of this is. Somebody pinged, or okay, I don't see any message here. Okay, so this is what this particular file system driver provides. And then what you have is file system driver is a hardware independent, but of course what you need is a hardware dependent part. It can be the IDE disk, it can be the SATA disk, it can be NVMe. So we need the driver which is specific to that hardware. So this is where you will be handling in a block drivers. So we have something called the file system driver and the block driver, and this forms the storage vertical. Great. So we have covered two verticals, two types of drivers, one which is a networking vertical and another one is the storage vertical. Now with that you might be wondering, how about all the devices of the world which we have? We have the camera driver, we basically have the video drivers, then we basically have the mouse, we have the keyboard, we have the sensors, all those kind of things. So all those drivers, because of their byte oriented transaction, they fall under this character vertical. So this is the majority bucket. Nearly 85% of the drivers will fall under this category. If you say video drivers, it will fall under this category. If you say the audio drivers, they are going to fall under this category. If you talk of the camera related stuff, it will fall under this category. If you talk of the terminal related drivers, it will fall under this category. So this is the majority bucket. So that means if you are comfortable with the character driver, you will be comfortable with most of the stuff which you will be dealing in the Linux kernel. And the good thing is, as a part of this particular Linux Rapid Mastery program, we already have this covered, where we are going to dive into this character driver related stuff. Now, character driver has been so vast that it has been further split into something like a TTY, input, output, video, audio, and all those video and sound, all those kind of stuff, as we will see. So there are multiple folders which will be containing the character drivers, and it's the majority bucket. And as a part of this particular program, we will be focusing on the character drivers. Okay, now that we understood that we have three verticals: networking vertical, storage vertical, character vertical, the another question which most of you might be having is, what about the USB? What about the PCI? What about the I2C? What about the SPI? We have not talked of those particular things. So in order to explain that particular thing, I typically take this example as something like, let's say I visit a electronic shop and I say, give me the USB device. Now, when you say USB device, the shopkeeper will be confused, and he might not be able to know like what exactly you are looking for. So he will be asking you, okay, whether you want the USB mouse, or are you looking for the USB pen drive, or you are looking for the USB network adapter. So there is nothing like a USB device as all. So similarly, there is nothing like a USB device driver. Okay, because it all depends on what functionality it provides, whether it is serving the functionality of the character driver. That means if you say USB mouse, it will fall under the character vertical. Then if you say USB pen drive, then of course it has to fall under this storage vertical. If I say USB networking related, if I say basically USB dongle, okay, USB to Ethernet converter, then it is going to fall under the networking stuff. So when you talk of the protocols like a USB, PCI, and all those things, it doesn't have any vertical associated, because it is to fall under, it will be cutting across the vertical. Depending on what functionality it has, it will be falling into any of these categories. So when you write a driver, you basically write a something like a USB to, I can say, character driver. Or let's say when you are writing a driver for the pen drive, you are writing a USB to block driver. Okay. And when you are writing a driver for the USB to Ethernet, you are basically writing a driver for USB to network. So your driver over here will be acting as a conversion layer, which will be converting a packets which are received from the USB to the corresponding, it will be basically converting a format. That means it will be converting into the format of the above layer. So if it is a USB dongle, of course it is going to plug into the networking vertical, and it is going to show this as a networking packets. So whatever packets you receive over USB, you show it as a packet. Over here, you will be showing it as a blocks. Here, you are going to show it as a bytes. I can say byte formatted as per the requirement of the mouse and keyboard kind of devices. So similarly, it's for the PCI. You let's say you have a PCI hard disk, for instance, or you let's say you have something like a PCI sound card. So you will get the packets in terms from the PCI. You are going to basically convert that format as per the audio. So that's how the things work. So that's why these all things, one of the question which you would have got is USB is what? It's a vertical. So USB is a horizontal. So all these things I call it as a verticals, and USB I call it as a horizontal. Horizontal means the protocol kind of things, the drivers which deal with a protocol. And then verticals are the one which deal with the user space.